Hello students, in the previous video of amplitude modulation we have understood the concept of amplitude modulation and we have seen the waveform in the time domain as well as frequency domain. So as we have seen in the frequency domain or even in the mathematical description of amplitude modulation, that amplitude modulation contains three terms. One is the carrier signal and the two sidebands. One upper sideband having the frequency omega c plus omega m and the lower sideband which is having the frequency omega c minus omega m. So this is we have seen in our previous video. Now there are few concepts related to amplitude modulation. The very first concept is the bandwidth of amplitude modulation. How we will calculate the bandwidth of the amplitude modulated signal. So bandwidth is nothing but the difference between the highest frequency component and the lowest frequency component. As you can see this frequency spectrum of the amplitude modulated signal, the highest frequency component is omega c plus omega m and the lowest frequency component is omega c minus omega m. So what would be the bandwidth? Bandwidth would be omega c plus omega m minus omega c minus omega m, which comes out to be bandwidth is equal to twice of omega m. So that means the bandwidth is twice of the frequency of modulating signal. So whatever signal you are transmitting, that is the information signal, it must contain some frequency. So twice of that frequency is known as the bandwidth of your amplitude modulated signal. So this is a viva question which usually asked in the practical vivas. So you must keep it in mind that bandwidth of amplitude modulated signal is twice of your modulating frequency or twice of the frequency of the modulating signal or the information signal. Okay. Next concept is the modulation index. Modulation index means in what depth your signal is modulated. So basically how the modulation is achieved, you are combining a low frequency signal which is the information signal with the high frequency signal, that is the carrier signal. So in what extent your carrier signal is mixed with the modulating signal or the high frequency signal is mixed with the low frequency signal. This is what the measure of modulation index. It is denoted by MA and it is the ratio of the amplitude of modulating signal to the amplitude of carrier signal, that is Vm upon Vc, and the range of this is always between 0 to 1. So modulation index range is between 0 to 1 always. So it is always less than 1. Another formula which is used to calculate the modulation index is Vmax minus V minimum upon Vmax plus V minimum. Now what is this Vmax and V minimum? When you measure or calculate the amplitude modulated signal, this part is the maximum voltage and this part is the minimum voltage. So this value is Vmax and this value is V minimum. So Vmax minus V minimum upon Vmax plus V minimum. Through this formula you can calculate the modulation index for AM signal. This diagram, the very first diagram, is known as under modulation, in which your modulation index is less than 1. After that, it is the second type of diagram. When you increase the amplitude of the modulating signal, after some time the V minimum becomes 0. This condition is known as the critical modulation, in which MA is equals to 1 because V minimum becomes 0. So it is Vmax upon Vmax, which is actually 1. So MA is equal to 1. It is the condition known as critical modulation. After this, if you increase the amplitude of your modulating signal, so basically what is happening, you are maintaining an amplitude of your carrier signal as well as the modulating signal. Initially the amplitude of modulating signal is less than the carrier signal. But when you keep on increasing the amplitude of modulating signal, at a particular instance Vm and Vc becomes equal. That time this condition is known as critical modulation. After that, if you increase the amplitude of your modulating signal, that is Vm becomes greater than Vc. So obviously numerator is greater and denominator is lower, that means Ma would be greater than 1. This condition is known as over modulation. So basically the small circle, this V minimum is basically a negative value because it comes after the zero value. So whatever measurements you are taking, this is basically a negative value. So anything negative will become positive and this will be deducted. So numerator will become greater and denominator will become smaller. So MA will become greater than 1. So this is the condition for over modulation. So these are the three types of modulation on the basis of their modulation index: under modulation, critical modulation and over modulation. So again, this is a topic which comes in the exam very often. What is modulation index in amplitude modulation? And the third topic is the power content in AM signal. So basically power in AM is power of carrier denoted by PC plus power of upper sideband plus power of lower sideband. As you can see, AM signal contains three components: carrier and two sidebands. So the power content of AM signal will be power content of these three elements, which is power of carrier plus power of upper sideband plus power of lower sideband. This power of upper sideband and lower sideband is equal to PC into MA square by 4. So basically upper sideband and lower sideband both contains same power, which is PC into MA square by 4. So by putting this value in this equation, we will get PT is equals to PC plus PC MA square by 4 plus PC MA square by 4, which is PC into 1 plus MA square by 2. So this is the power content of AM signal. Usually some numericals may come in the exam asking to calculate any of the three values. They will give you either the carrier power and modulation index, then you need to calculate the total power, or out of these three any two values will be given and the third element you have to calculate. So this is the power of AM signal. Now as you can see, in these three components, in this component only the carrier component, which is not our desired signal. What is our desired signal? Our desired signal is information signal which contains the frequency omega m. So that means our desired signal is only omega c plus omega m and omega c minus omega m. This carrier we don't need. So that means we can eliminate this part and we can only transmit the two signals like this. We need to eliminate the carrier. So this phenomena or this concept is basically known as double sideband. Obviously, when you will calculate the double sideband, that means you are eliminating the carrier. Your total power will become P USB plus P LSB. That means the power content will reduce. So that means as far as power is concerned, double sideband is beneficial in as far as AM signal is concerned, because in AM the power is more, in DSB or the double sideband power is less. Also, the double sideband are two sidebands. One is having omega c plus omega m frequency and another is having omega c minus omega m frequency. That means both the sidebands are having the information frequency. So what you can do is either you can transmit the lower sideband or you can transmit the upper sideband. In both cases you can get the desired frequency omega m. So obviously the total power in SSB, both these concepts are known as single sideband. So both these sidebands methods power content will be half as compared to DSB, because now the total power is either PUSB or PLSB. That means the power will come half than the DSB. So power content in SSB is more reduced. So anyways, this is just a concept regarding to power. That is why I am telling you all this thing. Now in the next video we will discuss in detail what is double sideband, how it is generated, how it is demodulated. Similarly, how single sideband is generated and single sideband is demodulated. So in the next video we will see both these topics. As far as in this video is concerned, we have covered three topics: bandwidth, modulation index and the power content in AM. If you have any doubt in these three topics, you can write it in the comment section.